Welcome back. This is still again 1.2.3 talking about electricity. This is going to be about Kirchhoff's law. This is going to be the largest, longest, and hardest of all of the PowerPoints that we've seen so far. So let's get started. Kirchhoff was a gentleman who came up with the idea. And first, in order to understand Kirchhoff's law, we got to understand what a series circuit is and a parallel circuit. A series circuit are when all the components are in line with each other. So here's a battery, here's a light bulb, and a mixer, for instance. If you remove this light bulb, all power will get cut and no electricity can flow through. Parallel is when the electricity has a choice. It can go through here, or through here, or through here. They have multiple choice. So if one goes out, not the rest of them go out. So this is kind of like how your bathroom light bulbs are. If one light bulb goes out, not all electricity in your bathroom goes out. On the other hand, this is Christmas trees, where one light bulb goes out, Christmas tree light bulbs all go out. Kirchhoff's law is these two statements. These are the laws, and I want you to write them down. Kirchhoff's voltage law says the sum of all voltage drops in a series circuit is equal to the total applied voltage. And we'll go over what that means here in a minute. Kirchhoff's current law says that the total current in a parallel circuit is equal to the sum of the branches. So let's look at a series circuit. If you take the light bulb out, both light bulbs go off. Not too hard to understand. So, series circuit. What this means is that the total current, the current here coming out of the battery, has to equal the current here, the current here, and the current here. The current does not deviate anywhere else. But the voltages add up. This voltage across here plus this voltage equals the sum of the voltages. And that's what this is. Now, in order to do this, you have to add up the total resistance. So to do that, it is just simply, if it's in a series circuit, is just add them straight up. You add the 220 plus the 470 plus the 1.2 kilo, that's 1,200. Add them together, and that gives you the resistance total. Once you find the voltages, you just add them together, and that should equal the 12 volts. So let's give an example. Here's the same circuit again, and what we're going to do is we're going to do it in we're going to have 4 steps. First step is find the total resistance, then get the total currents, or get the total currents and the subsequent currents throughout each of them, the voltages, and then finally verifying Kirchhoff's law. So first, total resistance, you just add them all straight up. 220 plus 470 plus the 1.2 kilo, or 1,200, and that gives you 1.9 kilo ohms, or 1,900. Then you need to get the total current, and to do that, we have the total voltage, which is the battery, 12 volts. We put that there. We just got the total resistance, the 1900. We put that there, and we get 6.3 milliamps. That's leaving the battery. Now, since we know that the electricity, the current's not going to deviate anywhere, there's no option. It has to go through here, has to go through here, and has to go through here. They're all equal to each other, 6.3 milliamps. Now, let's go look. Then we have the currents and the resistance. Now, all we have to do is just to find the voltages is multiply the 220 times this current, which we just got. So 6.3 milliamps times 220, 6.3 times the 470, 6.3 times the 1.2 kilos, and that gives us our various different voltages. Lastly, we add up all those different voltages, 1.3, 2.9, and 7.6, and that gives us our 12 volts. That is the series circuit. Now, parallel, though, is different. If I remove the battery here, electricity still can go through this area. So that is still good. Now, this is a little bit different. It's the 1 over the resistance total to figure out the total resistance. So it's 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Or if we rearrange it mathematically to get the resistance total, it's 1 over the 1 over 1 over 1 over. This is what I want you to write down. So now let's look. We got this new circuit. Now they're in parallel to each other. Notice how you have the branches here. So it's the total resistance is going to be 1 over this plus 1 over that plus 1 over that. So we're going to do the same thing. We're going to find the total resistance first, then the total currents, but this time voltages, because they're the same throughout it. The voltage is always going to be the same. 15 volts is equal to 15 volts, which is 15 volts, 15 volts. But the currents are going to, because the current split here, here, and here. So the current is going to split up. So this plus that plus this has to equal the total current. Notice this is just backwards from our series circuit. Now, what we're going to do is we're going to find the total voltages, then the total currents, and then verify the current law. So again, we plug it in, 1 over plus, 1 over plus, 1 over plus. Notice that you have to do this way. There is no other algebraic way of doing it. So we put 1 all over 1 over 470 plus 1 over 2.2 kilo or 2,200 plus 1 over 3,300. Again, you can just put this in your calculator and then take 1 over that whole answer. That's fine. And that gives you a total of 350 total ohms of resistance. Now, then we know, like I said before, that the voltages are the same. So 15 volts coming from the battery has to equal this, has to equal that, has to equal that. So that's easy. And now, because we know the resistance, the 470, and we just said that the 15 volts, we can get the currents. And it's really easy. It's just the 15 divided by 470, 15 divided by 2.2 kilo, and 15 divided by 3.3 kilo. And then lastly, we can get our total current, which is 15 divided by our total currents, which was the 346, and we get our various different currents. Now, to prove Kirchhoff's law, we just add up the currents. The 43, which is our total current we just got, is equal to the 31 plus the 6 plus the 4, which then again gives us our total numbers. Now we can combine them into combinations, and this is where it gets a little bit more complicated. So what would happen if you remove light 1? All of it would go out because this is in series with these two. What happens if you remove light 2? Nothing. It would just lighten the number 1 and number 3 would now be in series with each other. So if you have any further questions, please go ask your teacher.